Good morning, everyone. We are moving into quadratic applications. All right, so here's an SAT question. Try to use your common sense, see if you can figure this out. So it says John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing and then strictly decreasing? Now, we've never defined strictly increasing, strictly decreasing. So use some common sense. See if you can figure it out. Is it between 0 and 30? So 0 to 30. Is he strictly increasing and then strictly decreasing? Between 40 and 60, so that's from 40 to 60, is he strictly increasing and then strictly decreasing? 50 to 65, so would he be increasing and then decreasing? Or 70 to 90? Use yellow. 70 to 90. So the answer is B. Strictly just means you're actually increasing the whole time. You're not decreasing or staying flat. So in that one, he's going up, right? And then he's going down. Done, right? Increasing, going up, decreasing, coming down. So something like in this first one, from 0 to 30, he's going up and then he's staying flat. So that's not increasing or decreasing. So that doesn't count for the whole strictly thing. It has to be only increasing. Flat is not allowed. Okay. Make sure you can use your calculator for these. All right, if X represents the number of items sold and P of X represents profit, find the maximum profit of the following equation. So, maximum profit. Think about this equation, right? What's that an equation of? It's parabola. Is it an upward-facing or downward-facing parabola? Well, since there's a negative in front, right, that negative tells us it's down. Right? So where would the maximum be? The maximum is our vertex. Pretty much when you're doing application with quadratics, they're going to ask you either for the vertex, one of the roots. Those are the most common things that we do. All right, so how do you find the max? Negative b over 2a. Now, you can put this in the calculator. I think it's easier I use the calculator with my negative b over 2a and plugging in. I think that's the easiest way. So my b is 16, so negative 16 over 2 times negative 2. So that's negative 16 over negative 4, which is 4. Is 4 the answer? It wants the maximum profit. This is the number of items sold. X represents the number of items sold, right? So this is the items sold. We need to figure out the profit, which is P. So we're going to plug in now. So P, and then we're replacing our X with 4. P of 4 is negative 2, 4 squared, plus 16 times 4, minus 22. So I'm going to plug that in the calculator exactly the way I see it. 4 squared plus 16 times 4 minus 22. And the answer is 10. So the profit is $10. That's it. So maximum, find the vertex. Okay, little harder. A Portland High School quarterback is standing on the opponent's 40-yard line. He throws a pass toward the goal. It follows the parabolic path modeled by that. Let X be the number of yards and let Y be the number of meters. The ball is above the ground. Draw a real-world picture of what the situation looks like. All right, so start with A and B. So here's my quarterback. And there's the ball, right? And he's going to throw it in the air, and it's a quadratic, downward facing. So he's going to throw it in the air. It's going to go up, come back down. So there's my real world picture. He doesn't have a helmet on. Sorry. I can't draw a helmet. So now we're going to sketch the actual graph, right? So think about what's important to represent. So now we're only going to really deal with positive numbers, like we can find the roots and all that stuff, but I'm really focused on the positive side because in real world problems, it doesn't make sense to have negative yards. Well, I guess in football, negative yards does work. Or you can't be negative above the ground unless you're digging a hole in the ground. So pause, find the vertex, find the roots. Again, please use the calculator. These numbers are gross. All right, to find the vertex, it's actually a nice number. The vertex I got was 20, 14. So if you do negative b over 2a, negative 1.2 divided by 2 times negative 0.003, it actually comes out to 20. And when I plugged in, I got 14. So you can use the calculator however you want to do that problem. And then my zeros, or my roots, let's see what we get there. All right, so I use the calculator. You could do quadratic formula also if you want. I got negative 1.602, 0, and 41.602. And then the y-intercept is 2. What do you think the y-intercept represents in this problem? So it's 2 meters, right? So a meter is about 3 feet, right? It's the same as around a yard. So my guess is the quarterback is about 6 feet tall. So that would be like the quarterback. And so this is if he dropped the ball, I guess, and then it goes up, comes back down. So this is 41.602, and this is 2014. Now, doing all of this now will make the rest of the problems way easier because we're actually going to be using a lot of this information for the other problem, for the other parts of this question. Okay, how high is the ball when it crosses the 10-yard line? All right, so that we can't use from the graph. So what do you think? Crosses the 10-yard line. Well, what is X represent? X represents how far the ball went, so I'm pretty sure we're just going to plug in 10. Y of 10. If I plug in negative 0.03, 10 squared, unless I'm really bad and don't know anything about football, but I could be doing this wrong. I'm not super into football. If it was a basketball problem, I could help, but I got 11. How high? So it's 11 meters. That's pretty high. It's 33 feet. If nobody catches the ball, approximately where will it hit the ground? Now, we actually did find that. What's the word for ground in quadratics? That's the roots, right? The roots of a tree are in the ground. So what did we get for that? What was our root that makes sense? 41.602, right? That negative one doesn't really make sense. When does the ball reach its highest altitude? So we figured that out too. So when, that's our X value, right? That's a time. So at 20, I'm guessing seconds. Let's go back. Okay, so this is a poorly worded question. I went back and reread it. So the X is the number of yards. So the when would be when the ball reaches 20 yards. How high is it off the ground? That's the 14, right? 14 meters off the ground. It's really common for instead of the X to be the horizontal distance. A lot of times it's the time. This one's also weird because it's one of them is in meters and the other's in yards. Okay, I want you to pause. It's really similar to the last one. basically we're going to front load the sketch, right? Front load your sketch, find all your critical points and your your vertex, your roots, all of that. And if you do that, it'll make everything else super easy. Right, so now this one's kind of an interesting one because it's upward facing, right? So when I draw this, it's going to be something like that, is my guess, right? So either do negative b over 2a or use your calculator, whatever you want to do. I'm going to try negative b over 2a. So that's negative 24 over 2 times 2.4. It gives me 5. So the vertex is 5, comma, and I'm going to plug in 5. And I get 0. So that tells me that the vertex is the same as the roots. So this thing actually looks like this. At 5, so this thing looks like that actually. And then, so my roots are the same as my vertex. If I divide by 2.4, I get t squared minus 10t plus 25, which is t minus 5 times t minus 5. So the roots are and the vertex are the same. And then what's the y-intercept? That's our 60. All right. So now let's look at the questions. So I want you to pause, see if you can figure out the answers, especially B and C, you should be able to figure it out. How much water was in the tub when you pulled the plug? So when did you pull the plug, right? That's our t equals 0. That's just asking for our y-intercept. So there are 60, what is the units? Does it give us units? Liters. All right, 60 liters in the tub. When will the tub be empty? So when does the volume, right, V is the volume of the water, equal 0? If I set that equal to 0, well, we also have that. That's an empty. That's another thing for the ground, the roots, right? That's a 0. That's y equals 0. We already found that. T equals 5, right? So again, just front load all the stuff, and then you just have to figure out what it's asking. In the real world, the number of liters would never be negative. What is the lowest number of liters the model predicts? Is this number reasonable? So it's 0. So basically what's happening is at 5, it's 0. But then we have all this other stuff. That's, I guess, if we were to refill the tub. But we're not going to refill the tub. So t equals 0. I would say yes. This thing doesn't actually go, I guess it goes negative past 60. We just have to ignore the fact that t is not going to go negative, right? That doesn't make sense. And if t is greater than 5, we're no longer emptying anything, we're filling it again, right? So that's, I guess, what that would be. And that is it. All right, so assuming we didn't finish this in class, you were finishing this problem, and I will see you later. Do your homework. Bye.